All right, guys, so we left off, we were talking about this baseball example where you've got 9 players in the lineup and we're trying to arrange them into a batting order. So all of those 9 players will end up in the batting order somewhere. So we take 9 possibilities for the first spot times 8 possibilities for the second spot times 7 possibilities for the third spot, on and on until you're to that 9th spot and you only have 1 available player left to fill that spot. And so we multiplied these all together. We ended up with 362,880 possible lineups. And then we talked about how this is equal to just 9 factorial, remember, is what that exclamation point means. And we've got a button for that on our calculator. All right, and so I've got this little note that I want you guys to write down here. The number of permutations of n distinct objects. And now remember, n just represents some number. Maybe it's of 9 distinct objects, or it could be of 30 distinct objects. But the number of permutations, in other words, the number of ways you can arrange n distinct objects, is n factorial. And so remember, that exclamation point represents factorial. It is an actual math expression. Okay? So suppose in example 2, this baseball example we're talking about, you wanted to know how many different ways the players could be arranged in the infield. Just in the infield, and by that I just mean first base, second base, shortstop, and third base. We're not going to include the pitcher and the catcher in this. So how many different ways can the players be arranged in the infield? So we're still sticking with this idea that we've got 9 players to work with. So since nobody's been assigned to their position yet, for the first baseman, we've got 9 possibilities. So let's say for the first baseman, we've got 9 possibilities. And then that person has already been selected, they're in their position, we can't put them in any other positions. So then for the second baseman, that would leave 8 possible players. And then for the shortstop, now 2 of the people have already been assigned to their position, so that would leave 7 players that you could choose for shortstop. And then same logic here, 3 of the players have been selected already, so now that leaves 6 players that you could choose for your third baseman. So you're going to multiply these together, just like we did up above. The difference here is that we stop after we get the third baseman. Now the pitcher, the catcher, the outfielders, they haven't been assigned yet, and so we don't really care how the 5 remaining players get shuffled around. We're just trying to figure out how many different ways there are that you could arrange the players in those 4 positions in the infield. So we're going to multiply 9 times 8 times 7 times 6, and so that gives us a value of 3,024. So for this, there are 3,024 different ways that you could arrange those 9 players into the infield. So now remember, there are 9 players. We haven't given them all a position yet. We're just arranging 4 of those 9 players into the first 4 positions. All right, so what we're trying to figure out here, and this part gets a little bit tricky. Look at this original number up here, this 362,880. That's the number of ways that we can arrange all of the players. So that example specifically was talking about the lineup. Let's say we were talking about all 9 positions on the field, the 4 infield positions, the pitcher, the catcher, and then the 3 outfield positions. This would also count as the number of ways that you could arrange all of the players into the 9 different positions. And so there are 362,880 ways that you can assign 9 players into 9 different positions. Now there are only 3,024 ways that you can arrange 9 players into 4 different positions. And the reason there are such fewer numbers that you can do this is because we didn't take into account what the other 5 players are doing. So actually where this comes from, this number right here, is by taking the total number, which is 9 factorial, remember we wrote that up above, and then kind of dividing out the players that we didn't assign yet. So taking this total number up here and then dividing out the 5 players that we did not assign, which would be 5 times 4 times 3 times 2 times 1. So that, the 5 times 4 times 3 times 2 times 1, that ends up being 120, which means out of the 5 remaining players, there are 120 ways that we can assign them to pitcher, catcher, center field, left field, and right field. Okay, so we're taking this number right here and we're dividing out those 120 possibilities. So when we plug that into our calculator, and I'll show you guys how to do that. So we've got this button right here. Remember, if you hit the control key, and then if you hit the division key, up above the division key, there's this teeny little fraction button. So again, hit the control key first, and then hit the division key, and it gives you a fraction. So in the numerator, we're going to plug in 9 factorial. Remember yesterday where we found that? It's right by the G. There's this little button that has a question mark and an exclamation point. So click on that, and then it opens up this whole menu of symbols. So then you're going to take the exclamation point, which remember means factorial, and then arrow your way down into the denominator. In the denominator, we're going to put 5 times 4 times 3 times 2 times 1. Okay, and then if we hit enter, it gives us 3,024. So you get the exact same answer that way. So when we do it this way, it gives us 3,024. So what we actually just kind of came up with was a formula. And this is the formula that we're going to write down right here. So this is the permutations of n objects taken r at a time. So in our example, that would be the permutation of 9 objects taken 4 at a time. So what that means is, in an example like number 2, we are using up every single person, which means we go all the way from 9 down to 1. In this example that we just did, we're not using everybody. We have a total of 9 people to choose from, but we're only using 4 of them. And so that's what it means by the permutation of 9 objects taken 4 at a time, because we've got 4 different positions that we filled right here. Okay, so the formula, the number of permutations of r objects, so r is going to be a number, taken from a group of n distinct objects is given by, so now this is the notation. You write a little n, and then a big capital P, and then a little r. And so those are going to be filled in by numbers, like I said. You've got the little n, the little r. N is the total number in the group, which in our example up here was a 9. And then r is the number that you're taking. And so here we only took 4 for these 4 positions. So this is the notation. You'll see it in your book. You'll see it in your homework. The formula is you take n factorial in the numerator, just like we did up here. The total number that we were choosing from was 9. We put 9 factorial in the numerator. And then in the denominator, we take n minus r factorial. So here we took 9 minus 4, which is 5. And so this down here is 5 factorial. And what that does is it divides out the different ways that you could rearrange the 5 people that we didn't select. All right, so this is the formula that we're going to be using. Whenever the book asks you for this, they'll ask you for like 9p4. You just plug things right into this formula. And so we've got an example that's going to walk through that. Okay, so example 3, a photographer has matted and framed 15 photographs and needs to select 10 for a gallery show. How many ways can the photographer arrange the photographs for the show? So one of our keywords here is arrange. So to the photographer, it's important if he puts, one photo first and another photo second. He cares what order the photographs are going to be in around the room. And so when we care about order, we know we're talking about a permutation, just the way that someone might care about the order that their ice cream is put onto the cone. Okay, so when we are choosing from 15, that's our total number, that's n in this formula, our total number, and we're selecting 10 of them, so that's r in this formula. So we're going to write down 15 p 10, and so what this means is I've got 15 objects and I'm trying to figure out how many permutations of 10 of them I can take. So if I plug into the formula, remember the numerator is the total number factorial. So my numerator is 15 factorial, and then divided by, and in here I do n minus r, so 15 minus 10 factorial. All right, so let's simplify that up. So 15 factorial, we've got that set, and then divided by 15 minus 10 is 5, and so we've got 5 factorial. So what this is doing, 15 factorial would tell you the total number of ways that you could rearrange all 15 of the photographer's photos. But the photographer is not arranging all 15 of his photos. He's just arranging 10 of them. And so what you do is you divide out the number of ways that you could have rearranged the remaining 5 photos, because they're not included in the show. So you've got 15 factorial divided by the remaining 5 photos factorial. And so you can do this with your calculator. I'll show you how to do it in just a second. But it looks like this. 15 factorial, remember you start with 15 and you multiply all the way down to 1. It's going to take up a little bit of space here. Okay, so we squeeze that in there. So that's 15 factorial. Those are all the number of ways that the photographer could arrange 15 photos. But remember, he's not arranging 15 photos. He's only arranging 10 of them, which leaves 5 left over. So you need to divide that number by how many ways he could have arranged those 5 photos, because he didn't. They're left over. And so you see we've got some common factors. Both of them have a 5, which we can cancel out. Both of them have a 4, a 3, 2, 1. So we can cancel all these factors out. So our remaining piece just runs from 15 down to 6. So if you let me explain this really quickly, this is how many photo choices he has for the first photo out of 10. And then this is how many choices for the second, the third, fourth, fifth, sixth, 7th, 8th, 9th, and 10th. So remember, he's only choosing 10 photos for the gallery show, and so you've only got 10 choices. Okay, so this string right here we can plug into our calculator. I'm going to show you a couple different ways to do that. So the first option is to literally just type in exactly what I have on my paper, which is 15 times 14 times 13, 12, 11, 10, 9, 8, 7, 6. Okay, so we can plug that whole string in. What we end up with is an incredibly large number. So let me see. Looks like okay, so it looks like 10,897,286,400 different ways that the photographer could arrange 10 of the photos out of the 15 that he has. Okay, another way is to just plug it in from here, which I would accept as long as you have this written down first. So let me show you that way. So you can set up a fraction. So remember, hit the control button first and then hit the division key. And so that sets up a little fraction for you. Type in the 15 and then get the exclamation point from down here by the G. Press this button, and it opens up this menu. You can take the exclamation point. Okay, and then arrow down to the denominator, and then you can put the 5 factorial down in the denominator. So again, this button down here next to the G, select the exclamation point, and then when you hit enter, it'll give you the exact same answer. So 2 different ways to do it. One obviously kind of writes out all the information and shows you, and then we've got this way that works as well. Okay, so that's a couple of permutations. Another definition here, so now the second topic that we're going to be talking about is called combinations. Combination is a selection of distinct objects in which the order of the objects is not important. Okay, so this is a big idea. We're talking about permutations, we're talking about combinations. So the permutations, it's incredibly important what order the things go in. It matters if you choose the chocolate first, then the strawberry, then the vanilla. When you're talking about combinations, you might just be picking 3 flavors and you don't care what order they go in. So combinations and permutations have slightly different ideas, slightly different formulas. So to give an example, let's say you want to select three of 4 books. Okay, and rather than actually calling them things, let's just call our books A, B, C, and D. Okay, so I don't know, I mean, if you're at a bookstore, or if you're in something, you're just trying to select 3 out of 4 books that are available to you. If you take, so let me write this note here, so selecting, say you select book A, book B, and book D, and you take them home, and now you have 3 new books. That is no different than selecting B and D and A. Because at the end of the day, when you come home with your books, you've got the same 3 books, no matter what order you chose them in. So that might be an example of something that the order doesn't matter, whereas the ice cream example we keep bringing up, the order does matter. Okay, so combinations of n objects taken r at a time. So this, relating to this example here, would be a combination of 4 objects.